How do you make a buffer? One way is to mix reagents that will serve as a source for the conjugate acid-base pair. An example we just had earlier was acetic acid. HC2H3O2 is the conjugate acid. And when you do sodium acetate, NaC2H3O2, okay, your sodium acetate will give you acetate ions. That will be the source of your conjugate base. Okay, so how do you explain why a solution that's got comparable amounts of sodium carbonate and sodium bicarbonate works as a buffer? What acid does this give you? This breaks up in water to give you sodium ions and bicarbonate ions, right? What does this give you in water? Sodium ions and carbonate ions. Can you identify the two ions here that's a conjugate pair? This and that are a conjugate pair, right? So if you have significant amounts of bicarbonate and carbonate, then you can have a buffer. Okay, so that's one way you can make a buffer. You just mix a weak acid and the salt of the weak acid. Okay, so here's your weak acid and its salt, or you can mix two salts. Okay, so as long as they have the anions are what do you call them? Are a conjugate pair. The two. Another way you can prepare a buffer is to partially neutralize a weak acid by a strong base. Okay, for example, acetic acid, you can half neutralize it with sodium hydroxide. What would be the pH of that solution? And why would that work? Well, let's say you have a weak acid, HX, right? If you have and you add sodium hydroxide to it, gives you what does this give you? HX plus hydroxide. That's a complete reaction, because if you calculate the KEQ for this, it's going to be a big number. Weak acid plus strong base, pretty much a complete reaction. So that's going to give you X minus plus water. Okay, so if you start off, let's say, with 0.5 moles per liter of this, and you only add 0.25 moles per liter of sodium hydroxide, so let's just imagine that, okay, what would happen? What would be your changes? Reaction is going to go all the way, right? So which one's your limiting reactant? Sodium hydroxide. You're going to lose the 0.25 here. You're going to lose the 0.25 here, 0.25 over here. How much X minus will you make? 1-to-1 ratio, so 0.25. So at equilibrium, what will you have? You'll end up with 0.25 here, a trace amount here, and you'll have 0.25 here. Okay, so if it's half neutralized, what's the X minus to HX ratio in this case? If it's half neutralized, 0.25 over 0.25 is equal to 1. Okay, this is the Ka, by the way, not pKa. Make that correction. So what is the pH going to be? If the ratio is 1:1, pH is just going to be pKa, right? So pKa plus log of the ratio, which is 1. And what is pKa? Negative log of, so this is 0. Negative log of Ka, which is 1.8 times 10 to the negative 5. So that's going to be 4.74. I did that earlier. I gave you that pKa value earlier, right? Correct? Okay. Now, another way you can make a buffer is you neutralize a weak base by a strong acid. For example, let's say you have a solution, ammonia solution, okay? Let's neutralize that by HCl, so that gives you H+. The HCl will give you the H+, so that will give you ammonium ions, okay? Again, let's just make up some pretend numbers here. It doesn't really matter what numbers we use. Let's say we have 1 molar of ammonia to begin with, okay? So our initial concentration is 1. And let's say our H+ is, okay, if you're going to lose 40% of your ammonia, So you're going to lose 40%, right? Minus 0.4. How much H plus did you add then? 0.4. Because that 0.4 is going to be all pretty much gone. And how much ammonium will you make? Plus 0.4. Those would be your changes. Okay. So overall, at equilibrium, you would say you would end up with, instead of 1, you now have just 0.6 for the ammonia, right? 40% of it is gone. You have 0.6 left. And this will have, you have a trace amount of H plus. How much ammonium would you make? Also 0.4. So what's our pH here? This is pKa plus log of, what's the base over the acid here? This is your base, right? And this is your acid. So how do I know ammonia is the base? It's a proton acceptor. So this is going to be 0.6 over 0.4. I just need to know what pKa is for ammonia. Actually, pKa for ammonium, right? How do I know pKa? This is pKa of the acid, so I need the pKa of ammonium. Well, you can look up. You'll find pKb of ammonia is 4.74, okay? Or you might find Kb of ammonia to be 1.8 times 10 to the negative 5. You can look that up. So how do I get pKa of ammonium? What do we know about Ka and Kb for a conjugate pair? For a conjugate pair, Ka times Kb is Kw, right? That means pKa plus pKb, just like pH and pOH, they add up to 14. So if I know pKb of ammonia is 4.74, how do I get the pKa of ammonium? And I say pKa would be 14 minus pKb. Okay. Then I'll say that's 14 minus 4.74. So 14 minus 4.74 is how much? 9.26. So that's the pKa. So this is the pKa of ammonium ion. Right? So that's going to be my pH. That's what I plug in here. Okay. So this is, what was it? 9 point how much? This is how much? 9.26. 9.26. And what's log of 0.6 over 0.4? 0.6 divided by 0.4, that's 1.5. Take the log of that. That's 0.176. So what's 9.26 plus 0.176? Plus 9.26 is 9.43. Okay, that's the pH of your mixture. Now, let's see if this is reasonable. Okay, one way, that might help you out during tests is to see if numbers are reasonable. If the pKa is 9.26, okay, and you have more of the base, right? More base compared to acid. So you would expect your pH to be more towards the basic side of pKa, so higher than pKa. And in fact, 9.43 is higher than 9.26. Okay? So if you have more of the conjugate base, your pH would be higher than pKa. If you have more of the conjugate acid, your pH is going to be below pKa. If they're equal, then your pH is equal to pKa. Okay? So that's a good testing tip, like, especially if you're doing multiple choice and you're limited in time. That might be a way to eliminate some answers.